To build the chatbot, we will first import the necessary libraries such as NLTK, NumPy, random, string, and so on. For our example, we will be using the Wikipedia page for chatbots as our corpus. We will copy the contents from the page and place them in a text file named chatbot.txt. However, for this, you can use any corpus of your choice, but we will be using the Wikipedia page for chatbots as our corpus. Reading in the data. We will read in the corpus.txt file and convert the entire corpus into a list of sentences and a list of words for further preprocessing. We will open the .txt file in read mode and then convert it to lowercase. We will download the punct library function and also the wordnet function. We will tokenize the sentences into sentence tokens and word tokens respectively. Let us see an example of sentence tokens and word tokens. When we create sentence tokens up till the second sentence, we get the output as such, where two distinct sentences are separated with a comma and are stored. When we use word tokenization, we will get the required words as tokens, preprocessing the raw text. We shall now define a function called lemTokens, which will take as input the tokens and return a normalized tokens. We use the wordnet lemmatizer function to lemmatize the stem. Wordnet is a semantically oriented dictionary of English which is included in the NLTK package. We will define a function called lemTokens where we give the tokens as the input and which will return the lemmatized form of the tokens. We will then remove the punctuations in the sentences and return the text. Keyword matching. Next, since we shall define a function for greeting by the bot, that is, if a user's input is a greeting, the bot shall return a greeting response. Eliza, which was the first chatbot, used a simple keyword matching for greetings. We will use the same concept here. If the greeting inputs are hello, hi, greetings, sup, what's up, hey, and so on, the greeting responses will be hi, hey, nods, hi there, hello, I am glad you're talking to me, and so on. We will define a function called greetings with the sentences as the input, and we will split each word in the sentence, and if the words is in lowercase, we will generate a random choice of the greetings response. Generating the response. To generate a response from our bot for the input questions, the concept of document similarity will be used. So we begin by importing the necessary modules. The first one will be the scikit-learn library, and we will import the tf-idf vectorizer to convert a collection of raw documents to a matrix of tf-idf features. To perform this, we will use the command from sklearn.featureextraction.txt import tf-idf vectorizer. This command can be observed here. The next input will be the cosine similarity module from scikit-learn library, and to perform this we will use the command from sklearn.metrics.pairwise import cosine similarity. And so we will be importing the cosine similarity function from the sklearn package. This will be used to find the similarity between words entered by the user and the words in the corpus. This is the simplest possible implementation of a chatbot. We will then define a function response that searches the user's utterances for one or more general keywords and returns one of the several possible responses. If it doesn't find the input matching to any of the keywords, it returns a response as I am sorry, I do not understand you. This response will indicate to the user that the user's input was incoherent for the machine. To perform this, we will define a response function where we give the user's response as the input. We will tokenize and append the user's response. We will then use TF-IDF vectorizer to normalize and to remove all the English stop words. We will fit the transform of the tokenized sentences and check for cosine similarity between the user's input and the set of in inbuilt outputs or inbuilt responses the machine currently contains. And we will check if there is any match for the same. If there is, the respective response will be generated, and if there is no match, the response that says I am sorry, I do not understand you will be generated. Finally, we will feed the lines that we want our bot to say while starting and ending a conversation. If the the flag variable will indicate whether it is the ending of a conversation or not. If the flag variable says true, it will indicate and demarcate the ending of a conversation. And the final statement that will be printed is my name is Robo. I will answer your queries about chatbots. If you want to exit, type bye. Hence, if the user enters the word bye, the the robot or the chatbot will discontinue its conversation. To perform this, we will check if the flag value is true and if the user's response is bye, the robot will end the conversation. If not, it will continue the conversation with respect to what the user's input is. Here's an example of how we performed our machine. We see that the user is inputting questions where the robot is answering when asked who was Alan Turing. Background about Alan Turing is responded by the robot or the chatbot, and so on. The conversation takes place between the chatbot and the user. Though this was a very simple chatbot with hardly any cognitive skills, it was a good way to get started with the chatbots in NLP. This that we created responds to the user input. And for a production system of a well-built chatbot, you will want to consider one of the existing bot platforms or frameworks. But this example should help you think through and design and challenge for creating chatbots.